Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to fluid mechanics. So in the previous videos we discussed some basic concepts related to the pressure exerted by fluids and how to measure that pressure. We discussed simple application of barometer, mercury barometer and simple YouTube manometer. So in this video we are going to discuss about another important concept related to fluids which will be very important for the upcoming discussion that we want to have, which is intermolecular forces existing in fluids. Okay, so when it comes to fluids, uh, there are two types of intermolecular forces which are present according to the molecular theory. Now we know that according to the molecular theory, matter is made up of minute particles, small particles called molecules which attract each other. So in any matter, be it solid, liquid or gas, the intermolecular forces which are present, it is of two types. Now we have discussed a little bit about these things in the introductory concepts, but it was just in a quick way we discussed that without going into detail. So when it comes to hydrostatics or fluids at rest or fluids in motion, these intermolecular forces, they come into play, and they are the reason for various fluid phenomena associated with fluids such as surface tension, capillarity and all of that, surface energy. So these intermolecular forces, they can be divided into two categories: force of cohesion and force of adhesion. Now before we go into detail about force of cohesion and force of adhesion, let us discuss some important properties of molecular forces. So the molecules in solids and liquids which are separated by a distance of the order of 10 to the power minus 9 meter, and particularly for molecules of liquid and solid, in this case we are discussing about liquids, they have a force of attraction between them which is kind of a strong if the distance between them is less than 10 to the power minus 9 meter, in that range, and if it is more than that, the force, it becomes weaker, and as the distance becomes more greater than 10 to the power minus 9 meter, it becomes negligible. So this distance, which is the maximum distance up to which two molecules can have force of attraction, either cohesion or adhesion between them, just 10 to the power minus 9 meter, that is called as the molecular range, because when it exceeds 10 to the power minus 9 meter, the force, the molecular force of attraction, it becomes less and less until it becomes negligible. And this force of attraction between molecules, that is cohesion and adhesion, it is because of the electrical interaction between the charge existing in the molecules. And another important thing is that they do not obey inverse square law. Okay, 1 by r square, that law it does not obey. Okay, so these are some of the properties of molecular forces. Now force of cohesion and force of adhesion. Okay, force of cohesion first. Now the force of attraction between molecules of the same kind of a substance, same matter, okay, same thing, that is called as force of cohesion. Okay, so let us try to understand what force of cohesion is. Suppose we have two, let's say, water droplets. Okay, two water droplets, when they are brought closer to each other, okay, they combine to form one big water droplet. Okay, so this is because of the force of cohesion. Okay, this. Similarly, different materials which are of the same type, they have force of cohesion between the same substance, they have force of cohesion. Okay, so it is maximum in case of solids. That's why solids, they have a definite shape, size, and they do not change their shape unless force is exerted upon them. It is less in case of liquids. That is why they can easily change their shape, okay, and they take the shape of the container in which they are kept, because this force, cohesive force, is less in liquids, and it is the least, in gases. That's why they do not have a fixed volume, and the molecules, they're free to move in the in gases. Okay, so this is what force of cohesion is. Let's say we have a liquid placed in a container. So here the various molecules of liquid, okay, if we magnify the image, they exert force of cohesion, force of attraction between them. Likewise, like this. Okay, each molecule, each liquid molecule, it attracts the other liquid molecule towards it. And the interesting fact is that all the molecules which are within this whole thing, except at the surface, all the molecules, liquid molecules in this container, they are equally attracted by liquid molecules from all the other sides, and the net force on each liquid molecule is 0. Okay, because each force gets cancelled out by the opposite force which is exerted by the liquid molecule surrounding it. Okay, so this force of attraction between molecules of the same substance is called as cohesion, force of cohesion or cohesive force. It is not only for liquids. In case of solids, it is even more dominant. So in case of solids, the different molecules in it, okay, the different molecules, they exert force of cohesion, okay, which is of greater magnitude as compared to liquid. And that's why, because of that greater magnitude cohesive force, the molecules are tightly packed and they have a fixed shape and size and volume, okay, and they do not change it unless and until external force is exerted or acts upon them, causing them to change their shape or size. Okay, so in short, cohesive force is the force of attraction between molecules of the same substance, okay, same substance or same type of matter. Next is force of adhesion. Here also, force of adhesion is an attractive force, okay, it is a force of attraction, but in this case it is between molecules of different substance. Okay, so force of adhesion, it is different for different substances. For example, let us say we have a liquid which is contained in a solid container. Okay, the liquid is contained in a solid container. Here liquid is it can be water or anything. Solid, it can be anything, any container, aluminum type, iron type, or anything, even clay pot, it can be anything. So here the molecules of the solid and the molecules of the liquid, they have force of attraction between them at the boundaries, okay, where the liquid comes in contact with the solid at this point, okay, this at this point, the boundary where the liquid comes in contact with the solid. So at these points there exists force of adhesion, and here also cohesive force is there between liquid molecules. There is force of cohesion, and also between the solid molecules there is force of cohesion, but only at the boundary where the liquid is in contact with the solid there is force of adhesion. Let us try to understand it with this. Here, so you see, this is the force of adhesion. This one is the adhesive force, because it is the force of attraction between the solid molecules and the liquid molecules, which is only at the boundary. See, this surface and the sides, okay, the sides here, this one and this one at the sides, this one, and these are the cohesive forces. This is between the neighboring solid molecules, this is cohesive, this is adhesive, and this one also is cohesive between the two liquid molecules. Between the two liquid molecules, this is cohesive. So always understand, whenever there is force of attraction or interaction between two same kinds of substances, molecules of same kind of substance, be it solid solid or liquid liquid or gas gas, it is always cohesive in nature. And whenever there is interaction between two different kinds of substances, be it solid liquid or solid gas or liquid gas, whatever, liquid gas is very difficult to, you know, to analyze that thing, but normally solid liquid, solid fluid. So in that case, force of adhesion comes into play. So here the forces between solid solid and liquid liquid, okay, solid solid and liquid liquid, these are cohesive in nature. And the force of interaction between solid liquid, here also solid liquid, that is force of adhesion. This is cohesion, this is adhesion. So why force of cohesion and force of adhesion is important? So one very important practical explanation or practical example of force of cohesion and adhesion is that when we write on a paper with the help of ink, ink is fluid, paper is solid, the ink sticks on the paper and it does not, move in overflow in random directions, otherwise it would have been very difficult to read. The ink sticks to it, retains whatever shape or size we write, whatever structure we draw, so it keeps that shape fixed on the paper and does not overflow. It is because of the force of adhesion between ink molecules and paper molecules. Because this adhesive force is high, that's why ink, when we write on the paper, it retains the exact shape that we write or draw, or whatever alphabet or whatever picture we draw, or whatever shape and size we draw on the paper, it holds that shape, it does not overflow because of the adhesive force between liquid ink and solid paper. Okay, and that's why the adhesive force between ink and paper is greater than the cohesive force between the paper molecules or the cohesive force between the ink molecules. Another practical explanation is that when we write with the help of a chalk on a blackboard, here blackboard is a different kind of material, which is let's say one kind of a material, okay, the blackboard, and then we have chalk. Okay, so here they are different kinds of substances, their composition is different. So here, okay, there is adhesive force coming into play. Why? Because blackboard is made of a different kind of material, chalk is made of a different kind of material, there are different kinds of substances. So here adhesive force comes into play between the blackboard molecules and the chalk molecules. So since this adhesive force is high, we are able to write on the blackboard, and that the powdery structure or the powder of the chalk, it does not get even randomly distributed without retaining its shape. It retains its shape. Whatever we write on the board, it holds its shape because of the adhesive force between the blackboard molecules, that material molecules, and the chalk. It is greater than the cohesive force between the chalk molecules. Okay. So another important example is that when we drop water in a glass tumbler or anything like that, the glass tumbler becomes wet. Okay, it gets wet. So it is because of the adhesive force between the glass molecules, okay, the glass molecules and the water molecules. It is solid, it is liquid. So there is a force of adhesion between the solid glass and the liquid water. Okay, so because of this adhesive force between glass and water, water is able to wet the solid glass. Okay, so these are some of the practical examples of cohesive and adhesive forces. Another example is that mercury, it is not able to wet the glass in the same way water does. This is because adhesive force between the mercury molecules and glass molecules is less than the cohesive force between the mercury molecules. Cohesive force between the same substance, mercury molecules, adhesive force between the mercury and the glass molecules. The adhesive force is less, the force of attraction between glass and mercury is less, and the cohesive force or the force of attraction between the mercury molecules is high. That's why mercury is not able to wet glass in the same way water does, because in case of water and glass, the adhesive force between glass and water is high as compared to the cohesive force between water molecules. Okay, so these are some of the important concepts related to cohesive and adhesive forces or intermolecular forces. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.